Now let's see this finite group. A group with finite number of elements is called finite group. I think the definition is so trivial that I shouldn't have written it, isn't it? So if you have a group in which there are finite number of elements, then it is called finite group. The reason is, if you see the other real numbers, that is not finite. For example, if I say real numbers are set of all real numbers comma plus, that is a group, but then it is not a finite group because there are infinite number of numbers, which means you cannot count them. But the specialty of the finite group is the number of elements in the group will be limited, which means you can count it, and that is called as order of the group. It is generally represented by O of G, big O of G. So if G is a group, then order of group is nothing but the number of elements which are present in the group. Okay, so let's see some examples. Now if you have a set containing only one element 0, then 0 comma plus is a group. The reason why it is a group is it will follow all the properties. There is only one element, right, 0. So you take that element and you apply plus with the same element, then you are going to get 0, which is also present in the same one, which means it is closed, right? And we know that plus is already associative. And what about the identity element? In this case, identity element is 0 itself. So it is very important, remember this, whenever any group is having only one element, then that particular element is nothing but the identity element itself. That element is the identity element. Why should it be followed? Because if a group has to be, if you have to call something as a group, then definitely it should follow the monoid property. And what does monoid mean? That there should be an identity element. If there is only one element, and if you need an identity element so that it becomes a group, then definitely that particular element is going to be identity element itself. So make a note of this point. Any group containing only one element, that particular element is going to be the identity element, right? Therefore in this case the 0 is the identity element, right? And if you see this particular set, set containing one element which is 1, and if you have this operation star, now this 1 is again identity element, right? In fact, this is the only group with finite number of elements from the real number set, which is containing one element, or the only finite group possible under addition with respect to real numbers is only this one. You cannot get any other group. The reason is simple. If you try to get any other element into this set, for example, let us say you want to invite 1 into this set and also make it a finite group, then what happens is, once you bring 0 comma 1, and then if you put a plus, and if you try to make it a group, it will not become a group. The reason is, if you try to see 1, if you take 1 and the same element 1, and if you add them, the result is going to be 2, which is not present in this group. So in order to make this a group, you have to get 2 also into this. Now once you bring 2, you have to bring 4, you have to bring 3, you have to bring all the elements. That is why the only finite group with respect to addition under real numbers is going to be this group. This is the only finite group which is possible under addition, okay, with real numbers. Now similarly, check this one. Now this is the only group which is possible with one element under star. Okay, so why is it a group? It is definitely closed, and it is associative, which is star, and then identity element is there. What is the identity element? I told you that in this case the identity element is 1, right? And in any case, if a set has to be a group, then definitely that set has to have an identity element, and since it is having only one element, definitely that element is the identity element, right? In this case, this element is the identity element. What about the inverse? Yes, inverse is the same. So you can find out it is a group. Similarly, this one is also a group, right? So whenever you have 2, 3 or 4 elements, it is better that you write something as a tabular form. It is also called as composition table. Once you write the composition table, it will be clear that you can visualize whether it is closed or not, and then all the properties are satisfied or not. So what I mean to say is, in case of infinite numbers, we cannot test the closedness by taking every pair of elements. But then in case of finite elements, you can actually test it, and the best way to do it is using the composition table. Now see this, if you have this, if you want to test 1 comma minus 1, you can have the composition table like this: 1 minus 1 1 minus 1. Now you are applying the operation star. Now what is 1 into 1? 1. What is 1 into minus 1? Minus 1. What is minus 1 into 1? Minus 1. What is minus 1 into minus 1? 1 itself. Now if you see these elements which are result of the composition, which means by applying the operation, whatever we got, actually these elements are already present in this set. So what can we say? Closed property is satisfied. Therefore, writing this composition table, you can clearly see that whether closed property is followed or not. Yes, in this case closed property is followed, right? Now what about the other properties? What about associative? Since we are talking about multiplication, associative is already followed. And what about the identity element? Do you see any identity element? See this element 1. Now whenever you are applying this operation star with any of the elements, you are getting the same elements, isn't it? This entire row got replicated here, which means 1 is going to act as the identity element. Got it? Now what about inverse? Does inverse exist for each element? You can test it. You can take either a row or a column. Definitely there should be identity element in that. Then you can say that it is every element is having identity element. For example, if you take this particular column, this is having identity element 1. Therefore for 1 the inverse is 1. And similarly, if you take this, there is identity element minus 1 here, which means for minus 1 the inverse is minus 1. For 1 the inverse is 1, and for minus 1 the inverse is minus 1. Therefore for every element inverse also exists. So what can we say? That it is a group, right? And in case of real numbers with respect to multiplication, the only finite groups are these two. These two are the only finite groups. If you try to get any other number into picture, you will not get a group. For example, you might feel that let me get 2 into the picture and see if it is a group or not. You can test it. See this. If you think that 1, 2, only these two elements with respect to star, if you want to test whether it is a group or not, you can just draw the composition table and you can verify it. Directly you can answer it, but drawing composition table is better because you will not make any errors there. Now 1 into 1 is 1, 1 into 2 is 2. 2 into 1 is 2, but then 2 into 2 is 4. This is an element which is not present in the finite set. Therefore it cannot be a group because it is not closed. Got it? So the only finite groups which are the only sets, finite sets which can be groups with respect to multiplication will contain either only element 1 or two elements 1 and minus 1, nothing else. You can test it. Okay, now you can think that let me get 0 into picture. Maybe you might feel this way: the set containing 1 minus 1 0, right? 1 minus 1 0. You might think that this set could be a group, a finite group under multiplication. Let's see what happens here. 1 into 1 is 1, 1 into minus 1 is 1, 1 into 0 is 0, minus 1 into 1 is minus 1, minus 1 into minus 1 is 1, and minus 1 into 0 is 0, and 0 into anything is 0, right? Yes, it is closed, which means the result is going to be the same three numbers. It is closed. But let's see what about the other properties. It is definitely algebraic structure, and associativity is followed, therefore semi-group, and identity element is there. What is the identity element? 1 is the identity element. The reason why 1 is the identity element is, see this, for this element we are getting the entire row as it is, which means if you take this element and if you multiply this with any other element, we are getting the same elements. Therefore identity element is definitely there, and so it is monoid, right? Now let's see whether it is a group or not. In order to test whether it is a group or not, either you take all the rows or all the columns, there should be identity element somewhere. See this, for this element identity element is present here, which means for this element the inverse is 1, and for this element the identity element is present here, which means the inverse of minus 1 is minus 1. Are you getting this? How am I calculating it? For this element the identity element is present here, therefore inverse of this one is 1, Inverse of minus 1 is minus 1. I'm just checking where is it present, right? Now if you see this element 0, there is no identity element, which means if I take the element 0 and if I try to multiply with its inverse, I should get the identity element 1. But then in the entire row there is nothing like 1. So whatever element you multiply 0 with, you are never going to get the identity element. Therefore 0 is not having an inverse, and so it is not going to be a group. You can test it that way, but whatever you do, I can remember it this way. These are the only two groups which are finite with respect to multiplication under real numbers. If you try to get any other number into picture, that might not be a group. Okay. Now you can test this one, 1 omega square. So let's see this one, whether it is a group or not. 1 omega square. I think you know what are these. So these are the popular numbers, right? The cube roots of 1, which means if you try to find the cube root of 1, then generally how do you solve it? Let x equal to cube root of 1, right? Then how do you solve it? X cube equal to 1. That implies x cube minus 1 equal to 0. Now if you take this equation and solve for x, then we are going to get 3 roots. The reason is it is an equation of degree 3. Therefore we are supposed to get 3 roots for x, and the 3 roots for x is 1 omega and omega square. Now see this one, 1 omega and omega square. Now if you try to multiply them, what do we get? Here I get 1 omega square, because I am multiplying with 1, and if you multiply with omega, I am going to get omega into 1 is omega into omega is omega square, and omega into omega square is omega cube, and we know that omega cube is already 1, right? And what about omega square? Omega square into 1 is omega square into omega is omega cube, and we know that omega cube is already 1. In order to solve this question, only thing that you should know is omega cube is 1. This is what you should know. Okay, if omega is the cube root, one of the cube roots, okay, omega cube equal to 1. The reason is simple. It is going to satisfy this equation. What is the equation? X cube minus 1 equal to 0. So if you want to know what actually omega represents, you can just solve this and you can find out, but for this question it is not required. That is why I am just proceeding. Now here you are going to get omega into omega square, which is nothing but omega power 4, which I can write as omega cube into omega, which I can write as 1 into omega, which is omega. Therefore you are going to get omega here. Got it? So now if you observe it, all the elements present in this composition table are present in this set 1 omega and omega square. So closure property is satisfied, which means it is algebraic structure, and we already know that the multiplication star is associative, and so it is definitely semi-group. And can you find the identity element there? See this, for this element 1, you can see that all these elements are present as it is. So we also know that 1 is the identity element for multiplication anyway. Therefore identity element is there, so it is monoid. Now what about inverse? So is every element having an inverse? You can either test by row or column by column. Let's see this. Now in the first column we have 1 here. Now what does it mean? The inverse of 1 is 1, right? And again in the second column we have 1 here. What does it mean? Inverse of omega square is omega, or inverse of omega is omega square. And in the third column we have 1 here. What does it mean? Inverse of omega square is omega. Therefore for all the elements we are able to find out the inverses, and so it is a group. Got it? Now you can, on the same grounds, you can even check the this is the fourth roots of 1, right? If you try to find out fourth roots of 1, let x equal to fourth root of 1. If you try to see this, then you are going to get x power 4 minus 1 equal to 0, and if you try to solve it, you are going to get 1 minus 1 I and then minus I, right? So the reason is x square minus 1 into x square plus 1 equal to 0. You can solve it, okay? So you can clearly see that for this one 1 or minus 1, and for this one plus or minus I is the root. Therefore these are the fourth roots of unity. So this is also going to be a group under the operation star. You can check that if you need. Okay, so if you just put it in composition table, and you can verify it. I'm not doing it. You can verify it. In general, you can think of it this way: all the nth roots, if you take nth roots, all the nth roots of unity, and if you take the operation star, it is definitely going to be a group, which means cube roots of unity and star is a group, fourth roots of unity and star is a group. Similarly, nth roots of unity and star is going to be a group. So these are all the groups, some of the examples of groups, and then we can discuss some more examples. I don't have space here, I'll just continue. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.